Stacker, a new kind of 3D printer. Stacker can print multiple copies of an object at the same time in different colors with different kinds of filament. This means Stacker is at least 4 times faster than most other 3D printers. Who said 3D printing had to be slow? Stacker is the first truly commercial-grade 3D printer that's actually affordable. Stacker is durable enough for all-day work on your factory floor and safe enough for busy offices and schools. Stacker's Z-axis can expand to print 24-inch tall objects or just over 600 millimeters. Stacker is available in both desktop and mobile configurations. Stacker is designed to print with many filaments, including high-tech alloys which contain carbon fiber, Kevlar, PTFE, wood, bronze, copper, brass, and bamboo. Stacker is definitely a new kind of 3D printer. If you want to buy a 3D printer today, you have 2 choices: consumer-grade printers or really expensive commercial 3D printers. This leaves the largest segment of creators waiting on the sidelines or buying consumer-grade printers to fill the gap. These creators include design and engineering professionals, schools, colleges, research organizations, and almost every small and medium-sized company in the world. What the market wants is a commercial-grade 3D printer that's fast, reliable, and affordable. What we need is a new kind of 3D printer. Now, more creators can have fast, reliable, and large format printing at a fraction of the cost of other commercial printers. It's time to print your jigs, your architecture, your fossils, your artwork, your gears, your prototypes, your production parts, your medical devices, your big parts, your tall parts, your every part. Let's look closer at Stacker's key innovations, starting with multi-part printing. Why print 1 part at a time when you can get 2, 3, or 4 parts in the same amount of time? Welcome to the new age of digital manufacturing. Stacker's exclusive multi-part printing technology and high-volume extruders will print your objects many times faster than most other printers. Each printing head is adjustable to maximize the size of your prints according to how many extruders you are running. Stacker's modular design makes it easy to customize and add options. For example, you can increase the height of your Stacker by attaching our full-size frame option. Our fully locking casters turn Stacker into the ultimate mobile printer. If you want to double your printing height, then install our Z-axis height extender option. Use our half-size frame option to protect your printing heads. And finally, add extra hot ends and filament drives as you need them. Stacker's innovative new expandable Z-axis option will increase your print height from 220 millimeters to an incredible 600 millimeters. Imagine the possibilities of printing objects 24 inches tall. Our Z-axis uses an innovative new belt drive for fast, accurate, and maintenance-free operation. Most commercial printers force you into purchasing their own high-priced printing materials, not Stacker. Our universal filament rail accepts almost any filament on the market today, and this ensures your printing costs are priced fairly. Stacker will be offering a complete line of industrial-strength filaments from ColorFab. Their company philosophy is the same as ours: produce class-leading products that are innovative, functional, and safe for the end user. We partnered with ColorFab because they not only make excellent filaments in vibrant colors, but they are also pushing the boundaries of 3D printing with their new composite filaments, like XTCF20 filled with carbon fiber, and their PLAs with bronze, copper, and bamboo fillers. Here we are printing with our new carbon fiber filament, which uses Amphora 3D polymer from Eastman. We have been testing this revolutionary new composite filament on Stacker for weeks, and it's the best filament we've ever used. These carbon fiber prints have an extremely high flex modulus, which means they are really stiff. Unlike some stiff filaments, these prints are also tough and not brittle. It's everything you want in a filament: parts that are strong, stiff, tough, and accurate. Perfect for quadcopters, RC cars, and advanced prototyping in aerospace, automotive, and consumer products industries. Here is just a small sample of parts we printed on Stacker with our new carbon fiber composite filament, XTCF20. Notice the beautiful matte black surface finish and accurate features. There is no other 3D printing technology that can match the diversity of printing materials and colors you can use on your new Stacker. We gave Stacker a kinetic look that fits into any office, lab, or shop environment. Stacker doesn't look like an appliance because it's not. It's a productivity machine. There are no false bottoms and hidden compartments to hide the wires. Everything is out in the open and designed for easy access. This also makes modifying your stacker a straightforward and logical process, perfect for using Stacker as a development platform for alternative printing technologies. Finally, let's look at Stacker's all-new hybrid hot end. The hybrid gets its name because it uses interchangeable nozzle types. Each nozzle is engineered for a different filament melt temperature. Because of this, the hybrid hot end performs reliably with any filament. It also comes in many nozzle sizes, so you can choose the nozzle size that best fits your desired print quality and speed. Hybrid nozzles can be changed in less than 30 seconds. As you can see, just remove the heater block, unscrew the old nozzle, and install the new one. Finally, put the heater block back on, snap the wires together, and you're ready to print again. It's that fast and easy. We're on Kickstarter because we think more creators should have access to high-performance 3D printers, not just big companies with deep pockets. It is also important to show the world that 3D printing can be a lot faster. We also believe that 3D printers should use consumables that are priced fairly and safe to use in any environment. With your help, Kickstarter, let's bring affordable, commercial-grade 3D printing to more creators, just like you. Thank you, Kickstarter, for helping us launch our new printer. Together, let's bring high-performance 3D printing to the largest segment of creators on Earth. Stacker now makes it faster, bigger, and more affordable than ever.
I don't know what we're going to be doing in a few years, but I have a feeling that within the next couple of decades, it's not even going to involve things being delivered. I think it's going to involve 3D printing. Yeah. I think that's what it's going to be like. I want a new pair of Converse Chucks. I wonder if they'll be able to 3D print cloth. That's an interesting question.
Probably.
Why not, right?
Yeah.
What is that? 3D printer for fabrics. Well,
whoa.
Jamie just answered our question.
Crazy.
How does that work? Look at this.
Oh, shit. Wow. Look at it go.
You know, if nothing else, we've got an awesome Halloween decorator.
I know, right? They had this huge box that they sat down in the middle of the table. And they said, so this is what we do.
I met Aaron and the team when Fast Company first broke the story of Electrolume. He was still at Amazon, and they were considering making the leap to do this full time, but weren't really sure.
One day, I think a text came through where he told me that he was going to quit his job and he was going to do this full time. And I was horrified just simply because I felt very responsible. And the first thing I think I texted back was like, oh my God, have you told your parents? I gave the best advice that I could, which is, follow your heart.
After about 5 minutes of them talking, there was an actual object that had been created that was a cloth-like material. It was magic what they were doing in front of me.
I'm confused on what this is. It's like this.
I remember it was basically a barstool conversation with a friend, just talking about the clothes we wear and how we wanted to design them ourselves and how cool it would be if we had the technology to 3D print our clothes. You press a button and have a garment that was ready to wear. Immediately after coming up with the idea, we spent a lot of time on the floor in our rooms and garages trying to figure out how we could actually make clothes on demand.
Wow, we're actually getting a really nice tailor phone on some of these. Can you see a building?
There was a lab at our university that was doing tissue engineering. And in that lab, we were producing these small fabric scaffolds, which were then cultured and grown into these artificial blood vessels for research. The way we would make these scaffolds was by doing a process called electrospinning, which is basically taking liquid solutions and rapidly forming them into these fabrics. So the epiphany was, we're trying to make a garment, something that's made of fabric, it's composed of fibers, and just had this realization that the research we had been doing for years involved a process that, by its very nature, was making things composed of fibers on a very tiny scale. And we thought, hey, clothes we wear and other fabrics are just larger versions of that, so we basically just started scaling that technology up.
We spent months trying to refine this crazy idea into a usable machine that we could even interface with.
Well, nothing exploded, but it didn't work.
We built up a couple really crude, underdeveloped prototypes, and they got by, but they were not great. We went through 3 or 4 iterations like that here in the US, and then got the opportunity to go to Shenzhen, China, where we were able to make this into a slightly more usable product.
I'll give you a demonstration of some of the more simple things we've created so far. So this is a 2D sheet that was printed on the machine. So you can see it behaves like fabric. It's much different than a lot of the stuff coming off 3D printers today. Starting to get into the more complex realm, we basically just did a giant cylinder. What's cool about this though, you can see here it conformed to the cylindrical shape that was inside the machine, but it's seamless. We tried a pillowcase, it has some corners to it, here, and here.
Oh yeah, all right, let's go, baby.
Go really slow at the top though, because I don't want it to pull off, because that's the most critical part. We were super jazzed that the new machine was working, and so we were like, okay, we're gonna make a tank top. And so we really quickly sketched up a design, had a mold made, put it in the machine, ran it, took the tank top off, and it was, I think, 4 sizes too small for any of us. And so one of the program directors, Cyril, was like, oh, I'll take it home and have my daughter wear it. So they took it home, they decorated it, and they had her wear it, and it's like one of the cutest things we've seen. That was actually a first for us. Like, we ourselves hadn't worn things yet, but we were looking at his daughter like walking around the house in this dress now, and that was like the first time where, wow, we've actually made something that somebody used. And that was this moment of clarity for us. We can see the extension of that, which is what people could do in the future with us, and that was super exciting.
See it from that third, it's like a third arm.
Oh yeah.
After iterating prototype after prototype, I think we've created the closest thing to a 3D printer for clothing.
Components to the Electrolume Alpha. That's the pump itself, where we have these liquid solutions that eventually turn into fabrics. And those liquids are then delivered to a wall of nozzles that are charged to a high electric potential. And those nozzles then convert those liquids into fibers, where it enters the third component of the machine, where you have your mold, your tank top, your skirt, whatever it is, that then collects all of those fibers and forms a cohesive fabric.
There's a high barrier of entry to design, and I think a machine like Electrolume can really democratize it in a way that it can bring it close to the user, and I think that's really pretty powerful.
The most exciting thing about Electrolume to me is if you live in Ogallala, Nebraska, you can create a design on your computer, prototype it and manufacture it inside your home, and then with the power of the internet, distribute it and ship it out all over the world.
We've been designing Electrolume in a vacuum for the past couple of years. We've gone through a number of prototypes, and we're really ready to get outside perspective on them. We really want to engage with the community and open up this R&D process to other people so that we can improve the machines much quicker.
Our backers for this Kickstarter aren't really customers, and the Electrolume Alpha isn't really a product yet. It's a prototype.
We're initially releasing a limited number of Electrolume Alphas to the public on Kickstarter as a way of getting that early critical feedback for us. We're really looking for people that can open our eyes to new areas of design, things we haven't thought of, and help build this into a robust product.
I mean, it's really once every 10 years we see about 5 companies that define the next 10 years, and Electrolume can very possibly be one of those companies.